Is this some kind of joke? The words hung in the misty morning air of
Flag.
San Diego Naval Base
We have to do
as
this
Lieutenant
for all of
Nathan
us.
Blake stared at the elderly man who had just stepped out of an old Ford Galaxy. His pristine naval uniform contrasted sharply with the visitor's worn leather jacket and faded jeans. At 29, Blake stood tall and confident, MIT graduate and rising star of naval engineering. His perfectly trimmed hair and immaculate appearance reflected his meticulousness, a man who believed in precision and modern technology. The old man before him seemed like a relic from another era. 76-year-old James Sullivan moved with the unhurried confidence of someone who had nothing left to prove. His weathered hands told stories of decades working with engines and steel. He carried a simple toolbox, its surface scratched and worn from years of use. The old man's eyes scanned the naval base, settling on the massive silhouette partially obscured by the heavy June fog. The USS Sentinel DDG-3000 loomed in the distance, the most advanced stealth destroyer in the American fleet. Its angular design and sleek surfaces were built to vanish from enemy radar. But for 5 days, the $3 billion vessel had been crippled at port, its fuel sensors malfunctioning, despite the best efforts of the Navy's top engineers. The mighty warship sat silent, its mission delayed, its power dormant. Blake's voice dripped with condescension as he continued. Our most advanced technical team has been working around the clock. We have PhDs and specialists from the contractor, and they send us this. Sullivan said nothing. He simply looked past Blake toward the ship, his eyes narrowing slightly as if he were already diagnosing the problem from 100 yards away. The silence only irritated Blake further. Sir, I have 15 engineers under my command with advanced degrees. Whatever the Admiral told you, I can assure you we don't need. The sound of tires on wet concrete interrupted him. A military jeep approached rapidly, flanked by 2 security vehicles. Blake straightened his posture instinctively as the convoy stopped nearby. 4 naval security officers in formal dress stepped out, followed by Admiral Richard Montgomery. At 60, Montgomery carried himself with the authority of a man who had commanded fleets. His chest bore rows of service ribbons, each telling a story of dedication to country. His eyes, sharp and assessing, moved from Blake to Sullivan. And then something unexpected happened. Admiral Montgomery stepped forward and rendered a formal salute to the old man in the leather jacket. James Sullivan, been too long, my friend. Sullivan returned the salute with the precision of a man who had never forgotten his training, despite the decades since he'd worn a uniform. Admiral, ship's still giving you trouble. Montgomery nodded grimly. 5 days dead in the water. Nothing we've tried works. Blake stood frozen, the confusion evident on his face. The Admiral turned to him, his expression hardening. Lieutenant Blake, do you know who this is? Before Blake could answer, Montgomery continued, his voice carrying across the pier so that nearby sailors slowed their pace to listen. This is James Sullivan, Chief Engineer of the Atlantic Fleet during Desert Storm, the man who designed the original propulsion systems that your fancy computers are based on. He's saved more vessels than you've probably set foot on. Blake's face flushed red. His jaw tightened as he struggled to maintain his composure. Sullivan seemed unbothered by the introduction, his attention still focused on the distant silhouette of the USS Sentinel. I just need to see her, Sullivan said quietly. Been a while since I've been inside one of the new ones. Montgomery nodded and gestured toward the gangway. As they began walking, Blake fell into step behind them, his pride wounded but his curiosity growing. Who exactly was this old man that an admiral would salute him 20 minutes later? Sullivan sat alone in the officers' mess hall, studying maintenance logs while waiting for his escort to the engine room. The quiet moment offered a glimpse into the life that had brought him here. James Sullivan had never sought fame or recognition. His small home in a modest San Diego neighborhood was filled with memories rather than accolades. Every morning for the past 40 years, he woke at 5 a.m., brewed strong black coffee, and ate the same breakfast Navy biscuits made from his father's recipe. The radio played in the background, old music and news. No television, no computer. Just books, technical manuals, and his notebooks. In his study, Sullivan kept a glass cabinet, always locked. Inside lay a distinguished service medal and a Bronze Star honors earned during a career spanning from the Cold War through Desert Storm. He rarely spoke of them, even to his son Michael, who now worked as a financial advisor in New York, too busy to visit more than once a year. 5 years ago, Sullivan's wife Margaret had passed after 47 years of marriage. Her photograph remained on his nightstand. Her garden still bloomed in the backyard under his careful tending. He spoke to her sometimes when alone, updating her on the day's events as if she were just in the next room. What defined Sullivan wasn't grief or loneliness, but purpose. Throughout his life, one truth remained constant. He understood ships, not just their mechanical systems, but their heartbeat, their rhythm, the way they move through water. Ships spoke to him in a language of sounds and vibrations that few others could comprehend. His mind drifted back to 91, the Persian Gulf, during Operation Desert Storm. The USS Princeton had struck a mine, its engine room, flooding systems failing. 20 engineers had declared it would take days to restore power. Sullivan, then 42, had worked for 18 straight hours, often underwater in the damaged compartments. He'd restored auxiliary power in a way no manual had documented. The ship had limped back to safety, 87 souls aboard, who might otherwise have been lost. Admiral Montgomery had been a young lieutenant commander, then watching in awe as Sullivan performed what many later called a miracle. That day formed a bond between the men that 34 years hadn't diminished. Sullivan's weathered hands now traced over the USS Sentinel's maintenance logs, his finger stopping at certain entries, his brow furrowing slightly. The pattern was already emerging visible to him where others saw only isolated incidents. The mess hall door opened and Blake entered, his posture stiff. "We're ready to escort you to the engine room, Mr. Sullivan." Sullivan gathered his notes unhurriedly. "Tell me, Lieutenant, these replacements of the fuel sensors, always after routine maintenance?" Blake paused, caught off guard by the specific question. "Yes, but that's standard procedure. The diagnostics shows the sensor failing, we replace it." Sullivan nodded thoughtfully. "And yet it fails again. 3 times now. How did you know it was 3? "The logs, and the fact that I'm here." Sullivan stood, tucking his notebook into his jacket pocket. "After the 3rd failure, people start looking for answers outside the usual solutions." As they walked through the narrow corridors of the ship, sailors stopped and watched them pass. Word had spread about the old engineer called in by the Admiral himself. Some looked curious, others skeptical. Blake led the way with rigid formality, his back straight, his responses clipped. They reached the main engineering deck, where Chief Engineer Sarah Chen waited. Unlike Blake, the 45-year-old Chen's expression showed respect rather than skepticism. "Mr. Sullivan, it's an honor. Your paper on integrated fuel delivery systems from 1989 was revolutionary. We still reference it at the Academy." A hint of a smile crossed Sullivan's face. "Glad someone still reads the old stuff." Blake cleared his throat impatiently. "We have a schedule to maintain. The diagnostic station is this way." As they moved deeper into the ship, a young sailor named Thomas Rodriguez watched them from his workstation. The 22-year-old's eyes followed Sullivan with unusual interest. Later, when Sullivan paused near his station, Rodriguez spoke quietly. "Sir, my grandfather served with you. USS Enterprise, 1975. He still talks about how you saved the starboard propulsion system during that storm in the North Atlantic." Sullivan studied the young man's face. "Miguel Rodriguez, Engine Room Division." The young sailor's eyes widened. "Yes, sir. That's my grandfather." "Good man. Steady hands." Sullivan nodded. "Tell him Sully says hello." Blake, overhearing the exchange, couldn't resist commenting as they continued walking. "Time continues to waste away. Let's see if you can actually prove yourself, Sully." The corridor fell silent. Several technicians looked up from their work, sensing the disrespect in Blake's tone. Sullivan stopped walking, turning slowly to face the younger officer. His voice remained quiet but somehow filled the space. "No one has called me Sully since the USS Lexington nearly sank in '85. Not many left who earned that right." Sullivan's eyes held Blake steadily. Most of them didn't make it home. The weight of those words hung in the air. Without another word, Sullivan continued toward the engine room, leaving Blake momentarily speechless. Nathan Blake had graduated top of his class at MIT with a double major in computer engineering and artificial intelligence. His father, Senator William Blake of Connecticut, had made certain his son received an officer's commission without the inconvenience of basic training or sea duty. At 29, Blake had never served on a deployed vessel, never felt a ship roll beneath him in heavy seas, never had to repair equipment while exhausted and afraid. What he did have was confidence. Boundless, unshakable confidence in technology, in systems, in the superiority of modern engineering over outdated methods. His team had developed the integrated AI diagnostic system now standard on all new naval vessels. His name appeared on 12 patents. The Navy had fast-tracked him to his current position as head of the engineering division, specifically to oversee the USS Sentinel's maiden deployment. Standing now in the main engine control room, Blake watched Sullivan with poorly disguised impatience. The old man moved slowly around the space, occasionally touching a panel, placing his hand flat against a bulkhead, even closing his eyes at one point as if listening to the ship. "Mr. Sullivan, we have detailed diagnostic readouts here." Blake gestured to the main console. "Everything you need to know is in the system." Sullivan nodded but continued his methodical inspection. Chief Engineer Chen followed respectfully, occasionally answering his quiet questions. Young Rodriguez had somehow found reasons to be in the engine room as well, watching the proceedings with undisguised fascination. Admiral Montgomery entered his presence, immediately changing the atmosphere. Engineers straightened, conversations hushed. "James, what are you seeing?" Montgomery asked. Before Sullivan could answer, Blake interjected. "Admiral, we're following standard protocol. The sensor package is faulty. We've ordered replacements from the contractor." Sullivan finally spoke. "You've replaced it 3 times already. Same result each time." "Which means the connection to the sensor is faulty," Blake insisted. "We just need to trace the connection pathway." Sullivan shook his head. 2 years ago, I submitted a report on the potential interference between the new thermal monitoring system and the fuel pressure sensors on this class of vessel." A moment of silence followed this revelation. Chen looked from Sullivan to Blake with new understanding in her eyes. "You wrote that report?" she asked quietly. Sullivan nodded. "The design places the thermal monitor conduit too close to the fuel sensor array. Under certain conditions, particularly after full system diagnostics, the electromagnetic field from one affects the other." Blake's face reddened. That report was reviewed and dismissed. There was no evidence of interference in the simulations. "Simulations aren't ships," Sullivan said simply. "Ships move, they vibrate, they heat up and cool down. Metal expands and contracts." Montgomery turned to Blake. "Did you review that report personally, Lieutenant?" Blake straightened. "I led the review committee, sir. We found the concerns outdated and incompatible with the modular design philosophy of the Sentinel class." Sullivan didn't seem bothered by the dismissal. He simply reached into his worn leather messenger bag and pulled out a faded notebook. Flipping through pages of handwritten notes and diagrams, he stopped at a sketch that clearly showed the USS Sentinel's engine layout, with red circles highlighting certain connections. "The problem isn't the sensor itself, it's where it's placed in relation to other systems. The ship is telling you this every time that you run diagnostics after maintenance, but you're not listening." Blake scoffed. "With all due respect, sir, these systems are designed to be isolated. That's the entire point of the modular approach." Sullivan looked up from his notebook, his eyes meeting Blake's directly. "And that, Lieutenant, is exactly the problem. You've designed a ship of parts, not a whole. Real ships don't work that way." Admiral Montgomery's secure phone rang, interrupting the tense exchange. He stepped away to take the call, his expression growing more serious with each passing moment. When he returned, the atmosphere in the engine room shifted immediately. "We have a situation developing in the South China Sea. The Sentinel needs to be operational and ready to deploy in 36 hours. The pronouncement sent a ripple of tension through the gathered engineers. Blake's posture stiffened further. "Sir, we have replacement parts arriving tomorrow. We'll have her ready." Montgomery shook his head. "We've been down this road 3 times already, Lieutenant. I need certainty, not promises." Sullivan had returned to examining the engine schematics, seemingly untroubled by the pressure of the deadline. Blake watched him with growing frustration. "Admiral, with all respect, we need cutting-edge engineers for this vessel, not mechanics from the Cold War era." The words landed heavily in the quiet engine room. Several technicians exchanged glances. Chief Engineer Chen looked down at her tablet, uncomfortable with the blatant disrespect. Young Rodriguez's eyes widened in disbelief. Sullivan closed his notebook slowly. His voice remained calm but carried throughout the compartment. "Then by all means, Lieutenant, save your ship." The simple challenge hung in the air. Admiral Montgomery looked between the two men, the contrast stark. Blake young and arrogant in his pressed uniform representing the new Navy of technology and theory. Sullivan aged but unbowed in his worn leather jacket, embodying decades of hard-won experience and practical knowledge. Lieutenant Blake of Montgomery said finally, "Mr. Sullivan will have full access and authority to investigate his theory. You will provide any assistance he requires." Blake's jaw tightened, but he nodded curtly. "Yes, sir." As the Admiral departed, Blake turned to Sullivan. "So what's your plan? More walking around and touching things?" Sullivan considered the younger man for a moment. "First, I'm going to listen to what the ship is trying to tell us. Then we'll decide what she needs." The vast engine room of the USS Sentinel hummed with subdued activity as Sullivan began his true inspection. Unlike the cursory tour earlier, this was methodical and thorough. Chief Engineer Chen accompanied him, answering his questions and occasionally making notes on her tablet. Blake watched from a distance, arms crossed expression, skeptical. Sullivan had been aboard the ship less than 2 hours, but already he'd noticed something the others had missed. The slightest vibration in the starboard fuel transfer line, barely perceptible unless you placed your hand directly on the junction coupling. He felt it now, eyes closed, fingers splayed against the metal. "When did you last run the auxiliary generators at full capacity?" he asked Chen. She checked her records. 3 weeks ago during sea trials. "In the primary system diagnostics?" 5 days ago, right before the failure." Sullivan nodded, moving toward the main control panel. The digital displays showed normal readings across all systems except for the fuel pressure sensor that continuously registered critical failure despite being replaced 3 times. "I need to see the installation specifications for the thermal monitoring system," Sullivan said. "The actual installation report, not the design plans." Chen tapped on her tablet. "That would be in the contractor files. I'll have to request access." "I can pull that up," Blake interjected, stepping forward. He entered his credentials into the main terminal, navigating through several secure folders. "Here, thermal system installation was completed 8 months ago during the final outfitting." Sullivan studied the document, his finger tracing the installation path. "They modified the route. Original design had the thermal conduit running through section 23B. This shows it going through 23A instead." Blake frowned. "That's a minor adjustment for manufacturing efficiency. It doesn't change the functionality." "It changes the proximity to the fuel sensor array," Sullivan countered. "Instead of being 6 inches separated by a bulkhead, they're now less than 2 inches apart with only conduit shielding between them." Chen looked up sharply. "That would place them well within interference range if there's any electromagnetic leakage." Blake shook his head dismissively. "The shielding is rated for 10 times the potential field strength. This is exactly the kind of outdated thinking that the report committee rejected." Sullivan didn't argue. Instead, he pulled a small analog multimeter from his toolbox. "Chief Chen, can you power down the thermal monitoring for section 23 only?" She hesitated, looking to Blake, who reluctantly nodded. Her fingers moved across the control panel, and a section of indicators shifted from green to amber. "Thermal monitoring offline in section 23, she confirmed. Sullivan connected his meter to 2 points on the fuel sensor circuit. The needle fluctuated slightly, then stabilized. "Now restart the thermal system, but at minimum power," he instructed. As Chen complied, Sullivan watched his meter carefully. The needle jumped dramatically the moment power returned to the thermal system. "There's your interference," he said simply. "Every time you run full diagnostics after maintenance, the thermal system creates a field that affects the fuel sensor calibration. The sensor itself isn't failing. It's being told to report failure by interference." Blake moved closer, examining the meter readings with reluctant interest. "If that were true, it would affect other systems too." "It does," Sullivan replied, "but they have wider tolerance ranges. The fuel system is deliberately sensitive for safety reasons." He disconnected his meter and straightened slowly his back, clearly paining him after bending over the equipment. "Your ship isn't broken, Lieutenant. It's being misunderstood." The explanation was simple, elegant, and impossible to dismiss with the evidence literally displayed before them. Several engineers had gathered around, watching the demonstration with growing respect for the old technician. Blake struggled visibly between acknowledging the diagnosis and maintaining his authority. "If you're right, why didn't our diagnostic systems detect this interference?" "Because they're designed to check each system independently," Sullivan explained patiently. "The ship operates as a whole. Systems affect each other in ways that modular testing can't always predict." Young Rodriguez spoke up from nearby. It's like the ship is trying to tell us something, but we're only listening to one word at a time instead of the whole sentence. Sullivan nodded approvingly at the analogy. Exactly, son. Blake wasn't ready to concede. Even if this is the cause, we need a permanent solution, not just a theory. Oh, I have a solution, Sullivan said, but you might not like it. It involves modifying your perfect design. Before Blake could respond, Admiral Montgomery returned to the engine room, his expression grave. Sullivan, Blake, my ready room, now. The small group followed the Admiral to his shipboard office. Once the door closed, Montgomery activated a secure screen showing a satellite image of the South China Sea. A carrier group was clearly visible, moving steadily through contested waters. This situation is escalating faster than anticipated. We need the Sentinel operational and underway in 24 hours, not 36. Blake straightened. Sir, if Sullivan's theory is correct, we still need time to implement a proper solution. Sullivan studied the satellite imagery. What exactly is the mission, Admiral? Surveillance primarily. The Sentinel's stealth capabilities make her ideal for close observation without detection. We need to know exactly what they're doing out there. Sullivan nodded thoughtfully. So she needs to be fully operational with all systems functioning correctly. Absolutely, Montgomery confirmed. No makeshift patches or workarounds. We need her at 100%. Sullivan exchanged a glance with Chen. I believe we can do that, but it will require something unconventional. I'm listening, Montgomery said. We need to power down the entire ship, all systems, then bring them back online in a specific sequence that allows us to recalibrate the fuel sensors with the thermal monitoring system operating at various levels. Blake couldn't contain himself. That's completely against protocol, a full system shutdown, and could corrupt the AI navigation systems, the weapons targeting computers. We'd back everything up first, Sullivan countered calmly. But yes, there's some risk. Less risk, however, than sending a ship to sea with fuel sensors that might fail at any moment. Montgomery considered both men carefully. How long would this process take? 6 hours for the shutdown and sequential restart, Sullivan estimated. Another 4 for testing and verification. That's cutting it close for our departure window, Montgomery noted. Blake saw his opportunity. Admiral, I must formally advise against this course of action. It violates every safety protocol established for this class of vessel. Montgomery's eyes narrowed slightly. And your alternative, Lieutenant? We replaced the fuel sensor again, but this time with modified shielding around it. It's a targeted approach with minimal risk to other systems. Sullivan shook his head. You'd be treating the symptom, not the cause. The interference will eventually affect the new sensor too, or worse, it might affect something else that's harder to detect. The tension in the small room was palpable as Montgomery weighed the options. Finally, he turned to Sullivan. You have 6 hours to prove your theory. If at any point the ship's critical systems appear compromised, we revert to Lieutenant Blake's approach. Sullivan nodded. Understood. As they prepared to return to the engine room, Sullivan paused and reached into his pocket. He pulled out an old photograph and handed it to Montgomery. It showed a much younger Sullivan standing with a group of submariners in front of the USS Scorpion. Remember this? Sullivan asked quietly. Montgomery's expression sobered immediately. He nodded silently. We ignored the warning signs then. Sullivan continued, his voice low enough that only Montgomery and Blake could hear. The subtle vibrations, the electrical anomalies. Everyone said the systems were fine because the diagnostics showed green across the board. Blake looked between the two older men, suddenly aware he was missing something significant. What happened? He asked despite himself. Sullivan turned to him, his eyes reflecting an old pain. She went down in 1968 with 99 men aboard, because people didn't listen to what the ship was trying to tell them. The weight of those words hung in the air as they returned to the engine room. Blake remained silent, watching Sullivan with new eyes, seeing for the first time not just an old man with outdated methods, but someone who carried the weight of hard lessons learned at tremendous cost. The challenge had truly begun. Not just to fix a ship, but to bridge the gulf between generations, between theory and experience, between technology and the human element that no computer could fully replace. In the next few hours, both men would be tested in ways neither had anticipated when the day began in the misty morning at San Diego Naval Base. The main engineering bay of the USS Sentinel hummed with nervous energy. Word had spread throughout the vessel about the unconventional approach proposed by the elderly civilian. Sailors and technicians gathered at workstations, some openly curious, others skeptical. Lieutenant Blake had established a command post at the central console, issuing orders with crisp efficiency, his posture rigid, his voice tight with controlled tension. James Sullivan moved differently. Where Blake was all haste and command, Sullivan embodied patience and observation. He requested the complete error logs for the past 3 months. Not just the fuel system failures, but every anomaly, every deviation, every routine maintenance report. The file was massive, thousands of entries documenting the complex life of the most advanced destroyer in the American fleet. This will take hours to review, Blake objected, checking his watch pointedly. We have limited time. Sullivan didn't look up from the data tablet Chief Engineer Chen had provided. Sometimes you have to slow down to move faster. His weathered finger traced patterns in the data that others had missed, pausing occasionally to make notes in his worn leather journal. The log entries appeared random, to most observers, isolated incidents across unrelated systems. But Sullivan saw connections, relationships, the invisible threads that bound the vessel's systems together in ways the modular design philosophy had failed to account for. There, he said, finally pointing to an entry from 52 days earlier. And here 37 days ago. And again, 18 days ago. Chen leaned closer. Those are routine maintenance cycles. Sullivan nodded. Look at what happens in the 12 hours following each maintenance cycle. Micro fluctuations in the electrical distribution grid. Too small to trigger alerts, but present nonetheless. Blake reluctantly joined them, scanning the data points Sullivan had identified. Those are well within normal operating parameters. They're consistent, Sullivan countered. Same pattern each time. A ripple effect starting from the thermal monitoring system and propagating through adjacent systems. The fuel sensors are just the most sensitive component, the first to show visible symptoms. Young Rodriguez had remained nearby, ostensibly monitoring his assigned station, but clearly absorbed in Sullivan's investigation. Now he spoke up hesitantly. Sir, it's like when my grandfather taught me to work on his old Chevy. He said you have to listen to the whole engine, not just the part making the loudest noise. Sullivan gave the young sailor an approving nod. Your grandfather is a wise man. The comment triggered a memory. The Persian Gulf, 1991. Operation Desert Storm. Sullivan, then a senior engineering officer, instructing a team of young sailors aboard the USS Missouri. The massive battleship had been recommissioned for combat operations, its decades-old systems presenting challenges that modern naval engineers struggled to comprehend. The ship speaks its own language, Sullivan had told them, placing his hand against a bulkhead, vibrating with the distant rumble of the engines. Your job isn't just to fix what breaks, it's to listen before it breaks. One young ensign had asked, but sir, the diagnostic computers tell us when something is wrong. Sullivan had smiled patiently. Computers only know what we tell them to look for. Ships know things we haven't learned to ask about yet. That lesson had saved lives 3 days later when Sullivan detected a subtle change in vibration patterns that suggested a problem with the fire suppression system. The computerized diagnostics showed all systems operational, but Sullivan insisted on a manual inspection that revealed hairline fractures in critical valves. Had they failed during combat operations, the resulting fire could have been catastrophic. Now, 34 years later, Sullivan applied that same philosophy to a vessel generations more advanced. The principles remained unchanged despite the technology. Lieutenant Blake, Sullivan said, I need to see where the thermal monitoring conduit and the fuel sensor lines run parallel. Not in the schematics, but in the actual ship. Blake hesitated, then nodded to Chen. Take him to Section 23A. I'll monitor from here. Chen led Sullivan and Rodriguez through the narrow corridors and down 2 levels to a maintenance accessway rarely visited by anyone except repair crews. The space was tight, illuminated by recessed lighting that cast harsh shadows across the complex network of pipes, conduits, and junction boxes that comprised the ship's circulatory system. Sullivan ran his hand along a thick bundle of shielded cables. This is the primary thermal monitoring trunk line, Chen confirmed with a nod. Yes, it carries data from all temperature sensors forward of frame 180. Sullivan traced the line until it passed within inches of another conduit. And this is the fuel sensor pathway. Correct. That carries both power to the sensors and data back to the control systems. Sullivan pressed his ear against the junction point, closing his eyes. The faint hum of electronics was barely audible, but he listened intently, focusing on subtleties others might dismiss as background noise. "There's a harmonic vibration here," he said finally, "almost imperceptible. But when both systems are under high load, they create a resonance pattern. The shielding should prevent electromagnetic interference, but the physical vibration itself is causing micro-disruptions in the data flow." Rodriguez looked impressed. "You can hear that, sir?" Sullivan straightened with a small smile. 40 years of listening to ships, son. Your ears get tuned to it after a while." He turned to Chen. "The original design called for these pathways to be separated by a structural bulkhead. The revision that placed them adjacent saved space and materials, but created this vulnerability. It's not just electromagnetic interference, it's vibrational resonance, amplifying the effect." Chen's eyes widened with understanding. "So each time we run full diagnostics after maintenance, the thermal system operates at maximum capacity while testing?" Sullivan completed her thought. "That creates the strongest resonance pattern, which disrupts the fuel sensor calibration. The sensors themselves aren't failing. They're receiving corrupted instructions because of this physical proximity." When they returned to the main engineering bay, Sullivan explained his findings to Blake, who received the information with grudging interest. The younger officer might have been arrogant, but he wasn't stupid. The evidence was becoming difficult to dismiss. "If you're right," Blake said, "why wasn't this caught during sea trials? We pushed all systems to maximum capacity for sustained periods." "Because you never performed a full maintenance cycle immediately before those tests," Sullivan explained. "The maintenance process includes recalibration of the thermal sensors, which temporarily makes them more sensitive to feedback loops." Blake considered this, then posed a more challenging question. "And your solution, powering down the entire ship, seems extreme if the problem is localized to these two systems." Sullivan shook his head. "The problem is localized now, but it's a symptom of a design philosophy that treats the ship as isolated components rather than an integrated whole. The complete shutdown and sequential restart will allow us to establish new baseline calibrations for all interconnected systems, not just fixing this issue, but preventing similar problems from developing elsewhere." Blake's frustration was evident. That goes against every principle of modern naval engineering. Systems are modular specifically so they can be managed and repaired independently without compromising the entire vessel. "Ships aren't computers, Lieutenant," Sullivan said quietly. "They're living things. Every part affects every other part, whether your design philosophy acknowledges it or not." The fundamental disagreement hung between them, representing not just two approaches to a technical problem, but two eras of naval tradition. Blake saw ships as sophisticated machines, collections of cutting-edge components that could be optimized, upgraded, and replaced as technology advanced. Sullivan saw them as organic wholes, complex ecosystems, where the relationships between systems were as important as the systems themselves. Admiral Montgomery's arrival interrupted their philosophical impasse. His expression was even more grave than before. "The situation is escalating," he announced to the small group. "Satellite intelligence shows increased activity around disputed territories. The Pentagon wants the Sentinel on station as soon as possible to provide close surveillance." Blake straightened. "How soon, sir?" 24 hours, no extensions." The pronouncement sent a ripple of tension through the engineering bay. Sullivan exchanged glances with Chen, who looked concerned but determined. "We need to make a decision now," Montgomery continued. "Sullivan, are you confident your approach will resolve the issue within the time frame?" Before Sullivan could answer, Blake interjected. "Admiral, I must formally object once more. A full system shutdown carries significant risks. We could end up with more problems than we started with." Sullivan considered his response carefully. "Every repair involves some level of risk, Lieutenant. The question isn't whether there's risk, but which risk you choose to accept. Right now, you're choosing the risk of sending a ship to sea with a fundamental flaw in how its systems interact." The wisdom in those words was difficult to refute. Montgomery turned to Blake. "Your alternative proposal." Blake outlined his plan quickly. "Targeted replacement of the affected components with enhanced shielding, followed by a localized recalibration. It addresses the immediate issue without compromising other ship systems." Montgomery weighed both perspectives, aware that his decision would affect not only the mission, but potentially the careers of both men before him. Finally, he turned to Sullivan. Sullivan, you have 6 hours to implement your theory. If at any point the process threatens critical systems, we switch to Blake's approach. Is that understood? Sullivan nodded. Perfectly. As Montgomery departed, Sullivan turned to Chen. We'll need to prepare a complete backup of all system settings first, then develop a precise sequence for powering down and restarting each component. Blake watched them begin work, his expression a complex mixture of professional concern and wounded pride. The old man's approach contradicted everything he believed about modern naval engineering, yet he couldn't dismiss the logic behind it. Reluctantly, he joined them at the planning table. If we're doing this, he said stiffly, we do it by the book, my book. Sullivan didn't argue. Show me your book, Lieutenant, and I'll show you mine. 2 hours later, the atmosphere in the USS Sentinel's Combat Information Center was electric with tension. Admiral Montgomery stood at the central tactical display, surrounded by officers monitoring the developing situation in the South China Sea. The massive screen showed satellite imagery of foreign vessels moving through contested waters, establishing positions that violated international agreements. The Sentinel is our best option for close surveillance without detection, the Admiral explained to his staff. Her stealth capabilities allow her to monitor activity that satellites might miss, particularly underwater deployments. A communications officer interrupted. Sir, call from Fleet Command, Admiral Westfield for you. Montgomery moved to a secure console. The conversation was brief but intense, concluding with the terse "Understood, sir." When he returned to the tactical display, his expression had hardened. Change of plans. The Sentinel needs to be underway in 18 hours, not 24. Situation is developing faster than anticipated. Down in the engineering bay, Sullivan and his impromptu team had made significant progress. Chief Engineer Chen had helped develop a comprehensive backup of all system configurations, while young Rodriguez had proven unexpectedly valuable in mapping the intricate relationships between subsystems that official documentation overlooked. Blake had remained involved, his initial resistance gradually giving way to professional curiosity. The lieutenant wasn't ready to fully endorse Sullivan's approach, but he couldn't deny the old engineer's remarkable understanding of the vessel's integrated operations. The arrival of a messenger from the CIC brought news of the accelerated timeline. 18 hours. Blake's face paled slightly. That reduces our testing window significantly. Sullivan remained calm. Then we adapt. The principles remain the same, just the execution timeline changes. Chen looked up from her workstation. We've completed backups of all primary and secondary systems. Ready to begin shutdown sequence whenever you give the word. Sullivan nodded. We need to inform the Admiral of exactly what's going to happen. There will be moments when the ship appears completely dead in the water. He needs to be prepared for that. As if summoned by his name, Montgomery appeared in the engineering bay doorway. His presence brought everyone to attention. Progress report, he demanded. Sullivan stepped forward. We're ready to begin the shutdown sequence, Admiral, but I need to be clear about what this entails. For approximately 30 minutes, this ship will have no operational systems, no communications, no propulsion, not even emergency lighting beyond battery backups. Montgomery's expression remained neutral. In a combat situation, that would be unacceptable. In a combat situation, you wouldn't want failing fuel sensors either, Sullivan countered respectfully. This is preventative medicine, Admiral. Sometimes the cure requires a brief but controlled vulnerability. The Admiral considered this, then turned to Blake. Your assessment, Lieutenant. Blake hesitated, caught between his professional reservations and the growing evidence supporting Sullivan's approach. The procedure is unorthodox, sir, but the theory behind it is sound. The admission clearly cost Blake some pride, but Sullivan acknowledged it with a respectful nod. Very well, Montgomery decided. Proceed with the shutdown. I'll ensure the base commander understands the situation. As the Admiral departed, Sullivan turned to the assembled engineering team. We need to work in precise sequence. Chief Chen will coordinate the shutdown of propulsion systems. Lieutenant Blake will handle the sensor and monitoring arrays. I'll oversee the power distribution grid. Young Rodriguez, you're our timekeeper. Every step happens exactly according to schedule, not a minute early, not a minute late. The preparations continued with methodical precision. Throughout the massive vessel, crew members were briefed on the unprecedented procedure. Some viewed it with skepticism, others with nervous anticipation. Word had spread about the old engineer called in by the Admiral himself, and opinions divided largely along generational lines. Older sailors who remembered the days when ships were maintained more by human intuition than computer diagnostics tended to express confidence. Younger crew members raised in the digital age were more dubious. Sullivan moved through the preparations with calm assurance, occasionally stopping to place his hand against a bulkhead or close his eyes to listen to some barely perceptible sound. Each time he made minor adjustments to the plan, tweaking the sequence based on what the ship was telling him. As the moment of shutdown approached, Blake found himself watching the old engineer with growing respect. Despite his earlier dismissiveness, he couldn't deny Sullivan's extraordinary connection to the vessel. "How do you do that?" he asked during a brief lull in the preparations. "Know what's happening inside the ship just by touching it or listening?" Sullivan considered the question seriously. "When you've worked with enough ships, Lieutenant, you develop a sense for their rhythms. Every vessel has its own voice, its own patterns. The computers can tell you what they're programmed to monitor, but there's a whole conversation happening beyond those parameters." Blake looked skeptical. "That sounds more like mysticism than engineering." Sullivan smiled slightly. "The best engineering has always had an element of art to it. The numbers and specifications matter, of course, but so does the intuition that comes from experience." Before Blake could respond, Chen approached with the final checklist. "We're ready to begin the shutdown sequence, Mr. Sullivan." Sullivan nodded. "Inform the Admiral. Once we start, there's no stopping halfway." The message was relayed, and Montgomery's acknowledgement came back quickly. "Proceed." Sullivan took a deep breath, surveying the engineering bay one last time. Dozens of sailors and technicians stood at their stations, waiting for his command. Despite his civilian status, there was no question who was in charge of this operation. "Begin shutdown sequence," he ordered quietly. The process began with the peripheral systems gradually working inward toward the core power distribution network. Lights dimmed throughout the ship as non-essential systems went offline. Displays winked out one by one. The ever-present hum of ventilation systems faded to silence. Blake monitored the procedure with intense focus, ready to intervene at the first sign of trouble. But Sullivan's carefully orchestrated sequence proceeded smoothly, each system powering down exactly as planned. As the final primary systems prepared to shut down, Sullivan gathered the key personnel in the engineering bay. "When the main power goes offline, we'll have emergency lighting only. Battery backup systems will maintain minimal life support, but nothing else. Remember your assignments for the restart sequence. We move on my command, not before." The moment arrived. Sullivan himself pulled the main breaker that disconnected the USS Sentinel from all power sources. For the first time since her launch, the mighty warship fell completely silent. The sudden absence of the background hum that permeated every modern vessel was disorienting. In the dim glow of emergency lighting, the engineering bay took on an almost ghostly quality. Sullivan stood motionless, eyes closed, listening to the silence, feeling the subtle shift as the massive ship settled slightly deeper into the water, without the buoyancy provided by active systems. "Now we let her rest," he said quietly. "Just for a few minutes. Let everything return to its natural state." Blake checked his watch nervously. "We're on a timeline." Sullivan nodded. "I'm aware, Lieutenant, but some things can't be rushed. You wouldn't start your car immediately after major engine work without letting the fluid settle, would you, so?" The minutes stretched on, feeling much longer than they actually were in the darkened, silent vessel. Finally, Sullivan opened his eyes. "Begin restart sequence." The process of bringing the USS Sentinel back to life was more complex than shutting it down. Each system needed to be initialized in a specific order, with calibration checks at critical junctures. Sullivan moved between stations, confirming readings, occasionally making adjustments to the planned sequence based on how the ship responded. Blake observed with growing fascination as Sullivan seemed to anticipate issues before diagnostic tools detected them. When a power fluctuation occurred in the auxiliary electrical grid, Sullivan was already redirecting the flow before alarm sounded. When a cooling pump showed signs of cavitation during restart, he adjusted the flow rate by ear, restoring optimal operation without consulting the gauges. 3 hours into the restart process, they reached the critical junction where the thermal monitoring system and fuel sensors would come online. This was the moment of truth for Sullivan's theory. Power up the thermal monitoring system to 20% capacity, he instructed Chen. As the system activated, Sullivan monitored the fuel sensor readings closely. They remained stable, increased to 50%. Again, the fuel sensors showed no anomalous readings. Blake moved closer, his skepticism giving way to cautious optimism. Increased to 75%, Sullivan continued. At this level, previous tests had shown the first signs of interference, but the readings remained stable. Full power to thermal monitoring system. The moment stretched as everyone watched the fuel sensor displays. No alarms triggered, no error codes appeared. The readings remained perfectly within normal parameters. Chen broke into a broad smile. It's working. Sullivan nodded, allowing himself a small smile. The sequential restart established new baseline calibrations that account for the system's proximity. The ship now understands the relationship between these components. The success of the procedure rippled through the engineering team as each system came fully online without triggering the cascading errors that had plagued previous attempts. Sullivan continued to oversee the process, making minor adjustments, ensuring each system integrated properly with those already activated. As the final systems came online and the USS Sentinel returned to full operational status, Sullivan stepped back, watching the bustling activity around him with quiet satisfaction. The ship hummed with healthy energy, all systems reporting optimal function. Blake approached his expression, a mixture of admiration and lingering professional pride. I have to admit, I didn't think this would work. Sullivan shrugged. Ships want to work properly, Lieutenant. Sometimes they just need us to listen to what they're trying to tell us. Their moment of accord was interrupted by an urgent call from the CIC. Admiral Montgomery requested their presence immediately. Upon arriving at the Combat Information Center, they found Montgomery standing before the tactical display with several senior officers. The screen showed updated satellite imagery of the South China Sea situation, which had clearly deteriorated further. Status report, Montgomery demanded without preamble. Sullivan deferred to Blake, who stepped forward. All systems operational, Admiral. Fuel sensors functioning normally with no error codes or anomalous readings. The interference issue has been resolved, Sullivan added. The ship is ready for deployment. Montgomery nodded curtly. Good, because our timeline just changed again. The Sentinel needs to be underway in 6 hours. The pronouncement sent a ripple of tension through the CIC. Blake straightened. 6 hours is sufficient for final preparation, sir. We can be ready. Sullivan, however, frowned slightly. Admiral, I would recommend a brief sea trial first. Just a few hours to ensure all systems function correctly under actual operational conditions. Montgomery shook his head. No time. The situation is too volatile. This ship needs to be on station as quickly as possible. Before Sullivan could protest further, an alarm sounded from the engineering station. A young technician looked up with concern. Sir, we're showing a power fluctuation in the forward weapons grid. It just started. Blake moved quickly to the console. That's completely separate from the systems we were working on. Sullivan followed, studying the readings over Blake's shoulder. Not as separate as you think. The power distribution network connects everything. We need to check this before deployment. Montgomery's expression darkened. How long? 2 hours, Sullivan estimated. Maybe 3. You have 2, Montgomery stated firmly. Not a minute more. As they hurried back to the engineering bay, Blake's earlier confidence had been replaced by visible concern. This doesn't make sense. The weapons grid shouldn't be affected by anything we did. Everything is connected, Lieutenant, Sullivan reminded him. That's what I've been trying to tell you. On a ship this complex, no system truly operates in isolation. When they reached engineering, Chen already had a team tracing the source of the fluctuation. Her expression was puzzled as she reported to Sullivan. It's not in the power distribution network itself. The readings are stable there. It's something in the weapon system causing irregular power draws. Sullivan considered this. The new phased array radar system. When was it last calibrated? Chen checked the logs. 3 days ago, right after the last fuel sensor replacement. That's our connection, Sullivan realized. The radar calibration procedure includes a power cycling sequence that would have interacted with the thermal monitoring system. We need to check the radar housing immediately. Blake led the way to the forward weapons bay where the advanced radar system was housed. The space was dominated by complex electronic equipment, most of it classified technology that represented the cutting edge of naval warfare capabilities. Sullivan moved directly to a junction box where power cables fed into the radar housing. Using his multimeter, he tested various connection points, frowning at the readings. "There's electromagnetic leakage here," he announced. "The shielding has been compromised." Blake looked alarmed. "That could affect targeting accuracy." Sullivan nodded grimly. "Among other things, this needs to be repaired before deployment." As they began the process of accessing the radar housing, Sullivan paused, his hand resting on a nearby conduit. A subtle vibration had caught his attention, something barely perceptible, but distinctly abnormal. "Power down this section," he instructed, suddenly. "Now." Blake hesitated only briefly before giving the order. As the equipment fell silent, Sullivan pressed his ear against the junction box, listening intently. "There's something else," he murmured. "Something not showing on the diagnostics." Using a small inspection light, he examined the interior of the junction box more closely. In a corner nearly hidden behind a bundle of cables, he found what he was looking for: a hairline crack in a cooling conduit, leaking a small amount of fluid onto sensitive electronic components. "This could have caused a catastrophic failure at sea," Sullivan said quietly. "Coolant leaking onto high-voltage connections while the radar was operating at full power." Blake stared at the discovery, the implications sinking in. The sophisticated diagnostic systems had missed this developing problem completely. It had taken Sullivan's decades of experience, his ability to feel and hear what the computers couldn't detect, to identify a threat that might have endangered the entire vessel. "How did you know?" Blake asked, his voice subdued. Sullivan straightened slowly, wincing slightly as his aged back protested. "The ship told me, Lieutenant, just like they always do if you know how to listen." With the discovery of the radar system issue, Admiral Montgomery reluctantly granted additional time for repairs. The deployment was postponed by 4 hours, still urgently expedited, but with enough margin to ensure the ship would be truly ready for its mission. Sullivan supervised the repair of the coolant leak, personally working alongside Blake and a team of technicians in the cramped confines of the weapons bay. Despite the tension of the timeline, Sullivan maintained his methodical approach, refusing to rush procedures that required precision and care. During a brief break, while specialized sealant cured, Sullivan led Blake to a rarely visited section deep within the vessel. The narrow passageway ended at a small equipment room that housed auxiliary power distribution panels. "Few people come down here," Sullivan explained, "but it's where you can best hear the true voice of the ship." Blake looked around the unremarkable space with curiosity. "What do you mean?" Sullivan placed his hand on the bulkhead. "Stand here, close your eyes, listen." Feeling somewhat foolish but too intrigued to refuse, Blake did as instructed. At first he heard only the standard background sounds of the vessel, the hum of electrical systems, the distant rumble of ventilation, the occasional ping of metal expanding or contracting. "I don't hear anything special," he admitted after a minute. "You're listening with your ears," Sullivan said. "Try listening with your whole body. Feel the vibrations, the rhythm." Blake tried again, focusing more intently. Gradually, he became aware of subtle patterns in the sounds and vibrations, a complex interplay that seemed to flow through the ship like a pulse. "It's like a heartbeat," he said, finally opening his eyes with surprise. Sullivan nodded approvingly. "Every ship has one, unique as a fingerprint. When you know that rhythm, you can tell immediately when something changes, when something isn't right." The moment reminded Sullivan of another ship and another time. USS Forrestal, 1968. He had been a young petty officer, then assigned to the massive aircraft carrier's engineering division. The catastrophic fire that claimed 134 lives and injured 161 more had started on the flight deck, but its lessons had shaped Sullivan's entire approach to ship systems. "I was below decks when the fire started," Sullivan said quietly, lost in the memory. "Felt the ship change before any alarm sounded. A different vibration pattern, something wrong in her rhythm." Blake listened silently, sensing the weight of the story. By the time official word came, the fire was already spreading. Bombs cooking off on the flight deck, men dying. We worked to maintain power to the firefighting systems, to keep the engines running so the ship could turn into the wind to prevent the fire from reaching the ordnance magazines. Sullivan's eyes were distant now, seeing not the USS Sentinel, but that terrible day 57 years earlier. My best friend James Callahan was topside when it happened. He didn't make it. Neither did many good men. The official investigation focused on the accidental rocket launch that started the fire. But some of us knew there had been warning signs before that. Subtle changes in how systems were interacting. Nobody listened because the diagnostics showed everything within acceptable parameters. The story hung in the air between them, a somber reminder of the real stakes behind their technical disagreements. This wasn't merely about engineering philosophies or professional pride. Lives depended on understanding the true nature of how ships operated. That's why you insist on treating the ship as a unified system, Blake said with dawning comprehension, because isolating components can miss the interactions that indicate developing problems. Sullivan nodded. The most dangerous failures rarely announce themselves clearly. They whisper first. If you're only listening to each system individually, you miss the conversation between them. Blake absorbed this lesson silently. His entire career had been built around the modular approach to naval engineering, treating vessels as collections of discrete systems that could be optimized and replaced independently. Sullivan's perspective challenged that fundamental assumption, suggesting that the relationships between systems were as important as the systems themselves. As they made their way back to the weapons bay to check on the repairs, Blake found himself viewing the USS Sentinel with new eyes. The vibrations, sounds, and rhythms he had previously ignored or dismissed as background noise now carried information, telling a story about the vessel's condition that supplemented what the sophisticated diagnostic systems reported. The repair team had completed the sealing of the coolant leak and was now reassembling the radar housing. Sullivan inspected their work, carefully testing connections and ensuring the repaired section was properly isolated from sensitive electronics. The coolant leak is fixed, he announced finally, but we need to recalibrate the radar system to account for the power fluctuations it experienced. Blake nodded. I'll handle that personally. As they worked side by side, Blake ventured a question that had been forming since hearing Sullivan's story about the Forrestal. Earlier, you mentioned the USS Scorpion to the Admiral. That was the submarine lost in 1968, right? Sullivan's hands stilled momentarily. Yes, 99 men lost at sea. The official investigation never determined the exact cause. But you have a theory, Blake suggested. Sullivan resumed his work, his voice quieter. I was assigned to review some of the submarine's maintenance records after the fact. There were patterns there similar to what we've seen here. Systems interacting in ways the design specifications didn't account for. Subtle warnings that went unnoticed because they fell within individual tolerances, even while the combined effect was pushing toward failure. Could it have been prevented? Blake asked. Sullivan sighed heavily. With what we know now, probably. With what was known then, it would have required someone to challenge the entire approach to submarine maintenance. Nobody was prepared to do that, not without clear evidence. And once there was evidence, it was too late. The weight of those lost lives hung between them as they completed the radar system repairs. When the final test showed the system functioning correctly, Sullivan stepped back, allowing Blake to oversee the final reassembly. You know, Blake said as they prepared to report back to Admiral Montgomery, I still believe in the value of modular design and specialized systems, but I understand your perspective better now. There's a balance to be found. Sullivan nodded appreciatively. The best engineering always finds that balance, Lieutenant, between innovation and experience, between what the numbers tell you and what the ship itself is saying. When they returned to the CIC to report the successful repairs, they found Admiral Montgomery engaged in a tense conversation with a senior Pentagon official via secure video link. The Admiral acknowledged their presence with a brief nod, but continued his discussion. The Sentinel will be underway within 2 hours, sir. All systems are fully operational and mission ready. When the call ended, Montgomery turned to Sullivan and Blake. Report. Blake stepped forward. Radar system repairs are complete, sir. All weapons systems show green across the board. And the fuel sensor issue has been fully resolved, Sullivan added. The ship is ready for deployment. Montgomery studied both men, noting the changed dynamic between them. Where earlier there had been tension and mutual skepticism, now there appeared to be a grudging respect. Very well. Final preparations are underway. We deploy in 2 hours. The Admiral paused, then added, Good work, both of you. London, as they left the CIC, Blake turned to Sullivan. I need to oversee the final systems checks with my team, but I wanted to say, I was wrong about you and about some of my approaches to the ship. Sullivan accepted this concession with characteristic grace. We were both right about some things, Lieutenant, and we were both wrong about others. That's usually how it goes in engineering. The important thing is to keep learning. Blake nodded, then hesitated before asking one final question. That notebook you carry, 40 years of notes on ship systems. Have you ever thought about digitizing it, making it accessible to engineers like me? Sullivan smiled. Some things don't translate well to digital sun, but I'd be happy to show you more of what's in here while we still have time. As Blake departed to join his engineering team, Sullivan remained on the deck, feeling the mighty vessel preparing for its mission. The USS Sentinel was ready now, not just in its individual components, but as a harmonious whole. The ship had been speaking all along. Now finally those responsible for her care were learning to listen. With just under 2 hours remaining before deployment, Sullivan found himself once more in the main engineering bay. Chief Engineer Chen had coordinated final checks of all propulsion systems, confirming that the integrated restart procedure had resolved not only the fuel sensor issue, but several other minor anomalies that had previously been dismissed as within tolerance. Young Rodriguez had remained close to Sullivan throughout the process, absorbing every word of advice, every demonstration of the older man's techniques. The young sailor represented the future. Sullivan reflected someone who might bridge the gap between the technological sophistication Blake championed and the experiential wisdom Sullivan himself embodied. Blake had surprised Sullivan with his adaptability. Despite his initial arrogance, the lieutenant had shown a genuine willingness to learn once evidence supported Sullivan's approach. That combination of technical brilliance and openness to new perspectives would serve him well if he could maintain it. Sullivan was making final notes in his worn leather journal when the lights flickered briefly throughout the engineering bay. A moment later, they flickered again, then stabilized. Power fluctuation, Chen announced, moving quickly to the main distribution panel. Source unknown. Before she could begin diagnostics, every light in the engineering bay went out completely. Emergency lighting activated automatically, casting the space in a dim reddish glow. Alarm klaxons began to sound, then abruptly silenced, leaving an eerie quiet broken only by confused voices and the sound of people moving cautiously in the partial darkness. Complete power failure, Chen reported tensely. Backup systems are online, but main generators are non-responsive. Sullivan moved immediately to the central console, which showed minimal information on battery-powered emergency displays. Status of the reactor, he asked urgently. Scram initiated automatically, Chen replied, referring to the emergency shutdown procedure for the nuclear power plant. Safety systems functioning on battery backup. Sullivan processed this information quickly. Where's Lieutenant Blake? He was heading to the auxiliary power room to check some readings, Rodriguez answered. Section 42B, 2 levels down. Sullivan made a quick decision. Chen, try to establish communications with the CIC. Tell the Admiral what's happening and that we're investigating. Rodriguez, you are with me. They grabbed flashlights and emergency toolkits, then made their way through darkened corridors toward the auxiliary power room. The massive vessel felt different in darkness, more vulnerable. Somehow its technological sophistication rendered temporarily impotent by the power failure. When they reached Section 42B, they found the access doors sealed by the emergency lockdown protocols. Without power to the electronic locks, they would need to use the manual override. Sullivan located the hidden access panel and extracted the hand crank mechanism. Turn it clockwise until you feel resistance, he instructed Rodriguez. Then 3 more complete turns. As Rodriguez operated the crank, Sullivan prepared himself for what they might find. A complete power failure of this magnitude on a vessel as sophisticated as the USS Sentinel was nearly unprecedented. Something catastrophic must have occurred in the electrical distribution network. The door unsealed with a hiss of equalizing pressure. They pulled it open manually, revealing the darkened auxiliary power room beyond. Their flashlight beams cut through the darkness, eventually finding Lieutenant Blake hunched over an open access panel, his own flashlight gripped between his teeth as he worked on the circuitry within. Lieutenant, Sullivan called. Status. Blake looked up, relief evident on his face. Sullivan, good, I could use your help. They moved closer, and Blake explained the situation. I was doing a final check on the power distribution network when I noticed an anomalous reading, came down to investigate, and found a cascade failure in the main bus. Then everything went dark. Sullivan examined the open panel, his flashlight illuminating a complex array of circuit breakers and control modules. The main power coupling has fused, he observed grimly. Massive power surge through the system. But what caused it? Blake wondered. We checked everything during the restart procedure. Sullivan thought for a moment, mentally reviewing the ship's electrical systems. Then a possibility occurred to him. The new radar system. After we repaired the coolant leak, did you perform a full power test? Blake nodded. Standard procedure. It checked out fine. But the radar draws power in a specific pattern, Sullivan explained. If the coolant leak had caused more damage than we detected, the full power test might have created a delayed feedback loop through the electrical system. Understanding dawned on Blake's face. That would explain the timing. The feedback built up gradually until it triggered the surge. Sullivan was already moving to another panel across the room. We need to isolate the damage and establish a workaround to restore partial power. Without main generators, we can't deploy. Working in near darkness with only flashlights to illuminate their efforts, Sullivan, Blake, and Rodriguez began the painstaking process of tracing the damage through the electrical system. The task was made more challenging by the limited emergency lighting and the complexity of the USS Sentinel's power distribution network. Sullivan demonstrated techniques for diagnosing electrical systems without modern tools methods developed during his early career, when technology was less sophisticated and engineers relied more on direct interaction with the equipment. Listen to the transformers, he instructed Blake. A healthy transformer has a steady hum. Damaged ones produce a different sound, often with a rhythmic clicking or an uneven tone. Blake pressed his ear against a transformer housing, concentrating intently. I hear it. Irregular pattern, almost pulsing. Sullivan nodded approvingly. That one needs to be bypassed. It's not completely failed, but it can't handle full load. As they worked, Sullivan shared stories of similar challenges from his past, particularly during Desert Storm, when ships operating in the Persian Gulf faced extraordinary conditions. We repaired electrical systems under combat conditions, he recalled. No manuals limited spare parts sometimes while taking fire. You learn to improvise, to understand the fundamentals so deeply that you can adapt to any situation. Blake listened attentively, applying these lessons to their current predicament. Despite his extensive theoretical knowledge and technological expertise, he found himself learning approaches that no modern training program covered, techniques born from decades of practical experience in the most demanding circumstances. Rodriguez proved invaluable as well, his smaller hands able to access tight spaces that challenged both older men. The young sailor's eagerness to learn and his natural mechanical aptitude impressed Sullivan tremendously. You remind me of myself at your age, Sullivan told him during a brief pause. Always trying to understand how things really work, not just how the manual says they should work. After nearly an hour of intensive effort, they had mapped the damage and developed a plan to restore partial power. By bypassing the damaged sections and rerouting critical circuits through secondary pathways, they believed they could bring the main generators back online, though at reduced capacity. It won't be enough for full combat operations, Sullivan cautioned, but it should allow basic propulsion in essential systems. Blake nodded grimly. Enough to get back to port for proper repairs, but not enough for the mission. The reality of their situation hung heavily between them. The urgent deployment now seemed impossible, the sophisticated vessel reduced to limping home before it had even departed. Sullivan, however, wasn't ready to accept defeat. There might be another option, something unorthodox. Blake looked up with interest. I'm listening. If we reconfigure the emergency generators to operate in parallel, rather than sequentially, we could boost available power significantly. It's not in any manual because it exceeds design specifications, but I've done it before in emergency situations. Would it be safe? Blake asked. Not without risk, Sullivan admitted. We'd be pushing the emergency systems beyond their intended capacity. But with proper monitoring and management, it could work long enough to complete the mission. Blake considered this proposal carefully. A day earlier, he would have dismissed such an unorthodox approach immediately. Now, having witnessed Sullivan's extraordinary capabilities firsthand, he was willing to consider options outside standard protocols. Let's do it, he decided. Show me how. The next hour was spent in intense collaboration as Sullivan guided Blake and Rodriguez through the complex process of reconfiguring the emergency power systems. Using a combination of Sullivan's experience-based intuition and Blake's precise technical knowledge, they gradually assembled a solution that neither could have created alone. Throughout the process, occasional updates came through from Chief Engineer Chen via emergency communication devices. Admiral Montgomery was being kept informed of their progress, and the mission timeline remained unchanged for now. The situation in the South China Sea continued to deteriorate, making the USS Sentinel's deployment even more crucial. As they completed the final connections in their improvised power solution, Sullivan stepped back, wiping sweat from his brow, despite the cooler temperature in the darkened compartment. "Now comes the moment of truth," he said. "We need to initiate a controlled restart sequence. If the reconfiguration works, we should see emergency power levels at approximately 60% of normal capacity." Blake nodded, his earlier skepticism completely replaced by focused determination. That should be sufficient for limited operations. Not ideal, but functional. Sullivan placed his hand on the main emergency power coupling, feeling the subtle vibrations that told him more than any gauge could. Rodriguez monitored the output levels. Blake watched for any signs of overheating in the junction boxes. "I'll control the power flow manually to prevent surges." With practiced precision, Sullivan began the restart sequence, gradually increasing power through their reconfigured system. The emergency lights brightened noticeably as power levels rose. Throughout the compartment, equipment began to come online, displays illuminating with status information. "Power at 40% of normal capacity," Rodriguez reported, watching the emergency gauges. "Stable flow, no fluctuations. Junction temperatures rising, but within acceptable limits." Blake added, his hand resting on a power conduit to feel for excessive heat. Sullivan continued the methodical power increase, making minute adjustments based on the feedback from his companions and his own sensitivity to the system's behavior. 50%, Rodriguez called out. "Still stable." They pushed further, the improvised system responding better than any of them had dared hope. When the gauge showed 58% of normal power capacity with all readings stable, Sullivan eased back slightly. "This is our sweet spot," he announced. "We push harder, we risk overload. But this should be enough for limited operations." Blake straightened, a look of genuine admiration on his face. "I would never have believed this possible without seeing it myself. Nothing in my training covered anything like this." Sullivan smiled slightly. "Some things can't be taught in classrooms, Lieutenant. They have to be learned by doing, by facing real challenges with real consequences." Rodriguez looked between the two men, witnessing the completion of a transformation that had begun hours earlier. The arrogant young officer and the aging engineer had found common ground in the darkened heart of a wounded warship, each recognizing the value the other brought to their shared mission. As emergency lighting strengthened throughout the vessel and systems gradually came back online, Sullivan knew they had achieved something remarkable. The USS Sentinel wasn't at full capacity, but she was alive, responsive, ready to fulfill her duty despite the odds. Blake activated an emergency communication link to the CIC. "Admiral Montgomery, this is Lieutenant Blake. We have restored power to approximately 60% of normal capacity. Basic propulsion and essential systems are online. The ship is operational." After a brief pause, Montgomery's voice came through, tense but controlled. "Can we deploy with that capacity?" Blake looked to Sullivan, who nodded confidently. "Yes, sir," Blake responded. "We can deploy, not at full capability, but sufficient for the surveillance mission." "Well done," Montgomery replied. "Both of you report to the CIC immediately. We depart in 30 minutes. As they gathered their tools and prepared to leave the auxiliary power room, Blake turned to Sullivan. "I need to apologize for how I treated you when you arrived. I was..." "Young," Sullivan supplied with a small smile. "Confident in what you knew, unaware of what you didn't. We all start somewhere, Lieutenant." "I've learned more in these few hours than in years of formal training," Blake admitted. "Thank you for that." Sullivan nodded, acknowledging the sincere gratitude. "The learning goes both ways. Your technical knowledge made this solution possible. Neither of us could have done it alone." And together they made their way through the still, dimly lit corridors of the USS Sentinel, the mighty warship, wounded but unbowed, preparing to fulfill her mission despite the challenges. The unlikely partnership forged in the crisis had not only saved the vessel, but created something more valuable. A bridge between generations, between different approaches to the same fundamental challenge of keeping ships and sailors safe at sea. As they approached the CIC to report to Admiral Montgomery, Sullivan felt a profound satisfaction that transcended the technical problems they had solved. In Lieutenant Blake, he recognized a leader who might carry forward the best of both worlds, the technological sophistication of modern naval engineering and the experiential wisdom that no computer could replace. Perhaps that even more than the repairs themselves would be his most important contribution to the future of the fleet. The Combat Information Center of the USS Sentinel hummed with controlled urgency as Admiral Montgomery surveyed the gathered officers. The ship was operating at reduced power, but essential systems functioned well enough for their surveillance mission. On the main tactical display, satellite imagery showed the developing situation in the South China Sea, where foreign vessels continued positioning themselves in disputed waters. Deployment in 20 minutes, Montgomery announced. Despite our power limitations, this mission remains critical. The Sentinel is still the only vessel that can approach undetected. Sullivan and Blake stood side by side near the engineering station, their alliance forged through crisis representing a bridge between generations of naval knowledge. The contrast between them remained stark. Sullivan in his worn leather jacket, Blake in his pristine uniform. Yet the dynamic had fundamentally changed. Where once there had been contempt, now there was mutual respect. We should perform one final check on our power configuration before departure, Sullivan suggested quietly. Blake nodded. Agreed. I want to monitor the load distribution during the first hour at sea. If the emergency generators show any signs of strain, we may need to make adjustments. They excused themselves and made their way back to the main engineering bay, where Chief Engineer Chen coordinated final preparations with her team. The space was illuminated at reduced intensity, conserving precious power while maintaining operational capability. Status report, Blake requested as they entered. Chen looked up from her console. Emergency power holding steady at 58%. Propulsion systems configured for optimal efficiency under reduced load. Navigation and essential communications fully functional. Sullivan moved through the space with practiced eyes, his hand occasionally brushing against equipment, absorbing information through decades-refined senses that complemented the digital readouts. Unlike earlier, Blake no longer viewed these gestures with skepticism, but with growing appreciation. The port side emergency generator is running slightly hotter than starboard, Sullivan observed. Nothing critical yet, but we should adjust the load balance. Blake immediately began reconfiguring the power distribution network, his fingers moving confidently across the control panel. Shifting 7% of the load from port to starboard. That should equalize temperatures. As they worked through the final preparations, Rodriguez approached with a tablet displaying thermal imaging of the generator housings. The young sailor had proven himself invaluable during the crisis, combining respect for Sullivan's experience with an intuitive grasp of Blake's technical methods. Mr. Sullivan, I've been monitoring the thermal patterns. There's something unusual in the secondary cooling circuit. He handed the tablet to Sullivan, who studied it carefully. Good catch, son. That circulation pattern suggests we might have air bubbles in the system. They could create hotspots under sustained load. Sullivan looked up at Blake. We need to purge the cooling system before deployment. Blake checked the mission clock. We have 17 minutes. Can we do it? With help, yes. Sullivan turned to Rodriguez. Get the emergency purge kit from maintenance storage. Chen will need to reduce load on the port generator by another 5% during the procedure. The team worked with practiced efficiency, each member understanding their role. Sullivan guided the process. Blake managed the technical systems, Rodriguez handled the mechanical aspects, and Chen coordinated the power distribution. It was a seamless integration of experience and innovation, traditional knowledge and modern technique. With just 3 minutes to spare, the cooling system was purged, the generators stabilized, and the final checks completed. As Sullivan wiped his hands on a shop rag, Blake approached him. That could have been a serious problem during the mission if we hadn't caught it, Blake acknowledged. How did Rodriguez know to check the thermal patterns? Sullivan smiled slightly. I mentioned it to him earlier. In the Gulf War, we lost a generator to exactly that issue, air bubbles in the cooling system. The technical readouts don't always show it clearly, but the thermal imaging reveals the pattern if you know what to look for. Blake nodded thoughtfully. Another lesson that isn't in the manuals. The most important ones rarely are, Sullivan replied. A slight vibration ran through the deck beneath their feet as the USS Sentinel's engines powered up to departure levels. The massive vessel began moving slowly away from the pier, embarking on its critical mission despite operating at reduced capacity. Admiral Montgomery's voice came through the communication system. Engineering status report. Blake responded promptly. Power systems stable at 59% capacity, Admiral. Propulsion nominal. We've just resolved a potential cooling issue in the emergency generators. We're monitoring all systems continuously. Well done, Montgomery replied. Maintain current configuration unless absolutely necessary to make changes. We're running silent once we clear the harbor. The implications were clear. Once the stealth destroyer activated its full suite of signature reduction systems, communications would be minimal even internally. Any adjustments to the power distribution would need to be made with extreme caution to avoid detection. As the ship moved through the harbor toward open water, Sullivan found himself watching Blake. The transformation in the young officer over the past 24 hours had been remarkable. The arrogant lieutenant who had greeted him with contempt that morning was gone, replaced by a leader who combined technical brilliance with newfound humility and openness to learning. When Blake noticed Sullivan's gaze, he smiled slightly. "What are you thinking about, Mr. Sullivan?" "About how ships aren't the only things that can change their course when properly guided," Sullivan replied. The Pacific Ocean stretched before the USS Sentinel as it cleared the harbor and entered open waters. Despite its compromised power systems, the mighty warship cut through the waves with deceptive grace. In the engineering bay, Sullivan, Blake, and their team maintained a vigilant watch over the jury-rigged systems. "Approaching transition to cruise speed," Chen announced from the main console. This was the critical moment. The emergency power configuration had never been tested under sustained load conditions. As the massive engines demanded more power to drive the vessel to its operational speed, the improvised electrical system would face its greatest challenge. Sullivan placed his hand against the main power conduit, feeling the subtle vibrations change as the engines increased output. There was a rhythm to it, a pattern that told him more than any digital readout. "Port generator showing increased thermal readings," Blake reported, eyes fixed on the monitoring station. "Currently 5 degrees above normal operational maximum." Sullivan nodded. "Expected at this stage. How's the power output stability?" "Fluctuating within 2% of target levels," Blake replied. "The algorithm is compensating effectively." The ship continued its acceleration, the hull resonating with increased power as it pushed through the water. Sullivan moved methodically through the engineering bay, checking critical junctions, listening to the changing sounds of the vessel, occasionally making minor adjustments to systems that showed early signs of stress. As they reached 70% of cruise speed, a sharp metallic sound rang through the compartment, followed by a momentary fluctuation in the lighting. Warning indicators flashed on the main console. "Power surge in the starboard distribution node," Chen called out, her fingers moving rapidly across the control panel. "Backup systems engaging." Sullivan was already moving toward the affected area. "Rodriguez emergency toolkit. Blake, we need to isolate that node before the surge spreads." The next 3 minutes were a flurry of coordinated activity as they fought to contain the electrical surge that threatened to cascade through their fragile power configuration. Sullivan directed the operation with calm authority, his decades of experience evident in every decision. "Cut power to sections 12 through 15, he instructed Blake. "Reroute through the auxiliary bypass." Blake hesitated. "That will put additional strain on the port generator." "Only temporarily. We need to isolate the surge before we can diagnose the cause." Blake nodded, trusting Sullivan's judgment, and executed the commands. The affected sections went dark momentarily before backup lighting engaged. The warning indicators on the main console changed from flashing red to steady amber. "Surge contained," Chen confirmed. "Diagnostics running on the affected node." Sullivan knelt beside an access panel, Rodriguez at his side with the toolkit open. Together, they removed the panel, revealing a complex array of power distribution components. Smoke wafted from a junction box near the center. "Thermal relay failure," Sullivan said after a brief examination. "The emergency configuration is pushing it beyond design limits." "Can we replace it?" Blake asked, joining them. Sullivan shook his head. "Not easily. This is a specialized component." Blake frowned. "Without it, we can't maintain cruise speed. The mission would be compromised." Sullivan studied the damaged relay thoughtfully. Then he turned to Rodriguez. "Your grandfather ever tell you about the Kitty Hawk incident in '84? Rodriguez looked surprised. Yes, sir. The relay failure during the NATO exercises. That's right. We didn't have replacement parts then either. Sullivan reached into the junction box, carefully disconnecting the damaged relay. Blake, get me the secondary communications relay from storage compartment C. It's not designed for this application, but the internal components are similar enough. While Blake retrieved the parts, Sullivan explained to Rodriguez, sometimes engineering is about understanding the fundamental principles well enough to improvise when the standard solutions aren't available. When Blake returned with the communications relay, Sullivan began the delicate process of modifying it to serve as a replacement for the damaged component. His weathered hands worked with surprising dexterity, stripping wires, reconfiguring connections, and adjusting internal components. This goes against every safety protocol in the manual, Blake observed, though without criticism in his tone. The manual assumes you have the luxury of proper parts and facilities, Sullivan replied without looking up from his work. In a crisis, you have to understand the principles deeply enough to work around the limitations. 20 minutes later, Sullivan inserted the modified relay into the junction box, securing it carefully. This won't handle full power, but it should be stable enough at 70%. We'll need to redistribute the load to compensate. Blake nodded. I can reconfigure the distribution algorithm to favor the port side systems. And we'll need to monitor it constantly, Sullivan added. This is a temporary solution that requires human oversight, not just automated systems. With the improvised repair complete, they gradually restored power to the affected sections and resumed the transition to cruise speed, though at a more conservative rate than originally planned. The ship responded well, settling into a steady rhythm as it cut through the Pacific swells. 3 hours into the journey with the USS Sentinel, maintaining a stable 70% of its normal cruise speed, Admiral Montgomery summoned Sullivan and Blake to the CIC. The massive command center was operating it at reduced lighting to conserve power, giving it an almost submarine-like atmosphere. Status report, Montgomery requested as they arrived. Blake outlined the relay failure and their improvised solution, explaining the limitations and monitoring procedures they had implemented. Sullivan watched with quiet approval as the young officer presented a detailed technical assessment without hesitation or defensiveness. Montgomery listened attentively, then turned to Sullivan. Your assessment. The solution is holding, Admiral. We can maintain current speed indefinitely with proper monitoring, but we'll need to be cautious with any additional power demands. Montgomery nodded, then gestured toward the main tactical display. Our intelligence has been updated. Satellite reconnaissance confirms submarine activity in our target area. This changes our approach. He zoomed in on a section of the South China Sea where several vessels were clustered around a specific coordinate. We believe they're deploying advanced underwater surveillance equipment in this region. We need to get detailed sensor readings of exactly what they're putting down there. Sullivan studied the display thoughtfully. That will require enhanced Shisharwash and sensor operations. Additional power draw. Exactly, Montgomery confirmed. Can our current configuration handle it? Sullivan and Blake exchanged glances, both performing mental calculations based on their knowledge of the ship's systems. Not continuously, Sullivan answered honestly, but we might manage a focused burst of enhanced operations for a limited time. Blake nodded in agreement. If we redirect power from non-essential systems and implement a rotating load distribution, we could sustain 90% sensor capacity for approximately 3 hours. Would that be enough time? Sullivan asked. Montgomery considered this. It would be tight, but possible. We'll enter the surveillance zone in approximately 8 hours. The critical observation window is estimated at 2 to 3 hours. We should prepare the ship for enhanced operations now, Sullivan suggested. Test the configurations at reduced scale to ensure stability before we need full capacity. Agreed, Montgomery said. Make it happen. As they returned to engineering, Blake was already working on power distribution algorithms on his tablet. If we completely shut down all crew quarters except emergency lighting, reduce life support to minimal levels in unoccupied sections, and cycle the auxiliary systems in 30-second intervals, we might squeeze out an additional 8% capacity. Sullivan nodded approvingly. Good thinking, and we should prepare emergency protocols in case the modified relay can't handle the load. They spent the next several hours preparing the USS Sentinel for its critical surveillance mission, testing configurations, establishing backup procedures, and instructing the engineering team on emergency responses. Throughout the process, Sullivan found himself increasingly impressed by Blake's adaptability and creative problem-solving. When they finally reached the edge of the surveillance zone, the ship reduced speed further and activated its full stealth systems. The USS Sentinel became virtually invisible to radar and sonar, a ghost ship gliding silently through contested waters. Montgomery's voice came through the communication system barely above a whisper. Prepare for enhanced sensor operations. Estimated duration, 3 hours. Sullivan placed his hand on the main power conduit, feeling the ship's pulse. Ready when you are, Lieutenant. Blake nodded, his expression focused. Initiating enhanced sensor protocol in 3, 2, 1. The emergency generators whined as their output increased, providing the additional energy needed for the ship's sophisticated surveillance equipment. Throughout the engineering bay, monitoring stations displayed climbing power levels as systems drew additional energy. Port generator at 85% capacity, Chen reported quietly. Temperature rising but within acceptable parameters. Modified relay holding steady, Rodriguez added from his station. Sullivan moved through the space with heightened awareness, monitoring not just the readouts but the sounds, vibrations, and temperatures that told him the true story of the ship's condition. He made minor adjustments as needed, a touch here, a tweak there, maintaining the delicate balance of their improvised systems. The first hour passed without incident, the USS Sentinel gathering crucial intelligence on the underwater activities in the contested region. But as they entered the second hour, warning indicators began appearing more frequently. Port generator temperature now 10 degrees above operational maximum. Blake reported, his voice tense but controlled. Starboard following at 8 degrees above. Sullivan checked the modified relay, which was showing signs of strain. We need to implement cooling measures. Rodriguez, redirect auxiliary coolant flow to the generator housings. The young sailor complied immediately, rerouting systems to focus on the overheating generators. It was a temporary measure but might provide the additional time needed to complete the mission. As they approached the 3-hour mark, the situation became increasingly critical. The emergency generators were never designed to maintain such output levels for extended periods, and the modified relay was approaching its limits. Port generator at 92% capacity. Chen announced, alarm evident in her tone. Temperature critical. Sullivan made a quick decision. Begin emergency cycling procedure. 30 seconds reduced load, 90 seconds full capacity. It will extend our operational time. The strategy worked, allowing the generators brief recovery periods while maintaining the overall mission capabilities. But as they entered the final 30 minutes of the surveillance operation, a sharp crack echoed through the engineering bay, followed by a shower of sparks from the modified relay. Relay failure imminent, Sullivan called out. Blake, emergency protocol 3. Without hesitation, Blake initiated predetermined emergency response, redistributing power through secondary pathways and isolating the failing relay. The ship's lights dimmed momentarily, then stabilized at a reduced level. We've lost 15% capacity, Blake reported, operating at minimum viable levels for sensor operations. Sullivan moved quickly to the damaged relay. Rodriguez, emergency bypass kit. Together, they worked feverishly to establish a direct connection around the failing relay, a dangerous but necessary measure to maintain essential operations for the remaining minutes of the mission. Admiral, Blake communicated to the CIC engineering, reporting critical power configuration. Estimate 20 minutes remaining before mandatory shutdown. Montgomery's response was tense. Understood. 17 minutes to mission completion. Hold it together. The final countdown was a battle against physics and engineering limitations. Sullivan, Blake, Chen, and Rodriguez fought to maintain the fragile power balance, making constant adjustments, cooling overheating components, and redirecting energy flows to prevent catastrophic failure. With just 2 minutes remaining before their self-imposed shutdown deadline, word came from the CIC. Surveillance operation complete. Return to standard operational parameters. The relief in the engineering bay was palpable as they began the careful process of reducing power levels, allowing the strained systems to cool gradually. Blake initiated the power reduction sequence, his movements precise despite the exhaustion evident on his face. We did it, he said quietly to Sullivan. Actually did it. Sullivan nodded, his expression showing both satisfaction and respect. You did well, Lieutenant. All of you did. As they stabilized the ship's systems and began assessing the damage, Admiral Montgomery's voice came through once more. The intelligence gathered during this operation is already being analyzed. Initial assessment indicates we've identified a previously unknown underwater surveillance network. Well done, all of you. Prepare for return to San Diego at best possible speed. In the relative quiet that followed as the engineering team established watch rotations for the journey home, Blake found a moment to speak privately with Sullivan. "When I dismissed you this morning, I thought I knew everything about naval engineering," he admitted. "I've never been so wrong about anything in my life." Sullivan smiled slightly. "Being wrong isn't the problem. Not being willing to learn from it is." Blake nodded thoughtfully. "I'd like to learn more about how you understand ships, how you listen to them. If you're willing to teach me." "I think that could be arranged," Sullivan replied, "though I suspect we might end up teaching each other." The journey home proved more challenging than anticipated. 2 days into their return voyage, the USS Sentinel encountered a powerful Pacific storm system that had developed unexpectedly off the California coast. Massive waves pounded the vessel as hurricane-force winds created treacherous conditions. In the engineering bay, Sullivan and Blake fought a constant battle to maintain the fragile power configuration. The stress of rough seas placed additional demands on systems already operating beyond their design limitations. "Port emergency generator showing power fluctuations," Chen reported as a particularly massive wave crashed against the hull. "Compensators struggling to maintain stability." Sullivan moved to the generator monitoring station. "The mount brackets are working loose. The vibration is disrupting power flow." Blake joined him, examining the readouts. "Can we reinforce them?" "Not while they're running," Sullivan replied. "We'd need to power down the port generator completely. That would leave us at less than 40% capacity," Blake calculated quickly. "Barely enough for essential navigation in these conditions." Sullivan considered their options, his experienced eyes scanning the engineering bay thoughtfully. "There might be another way. Rodriguez, remember those shock absorber pads we salvaged from the storage compartment?" The young sailor nodded. "Yes, sir. We have 4 remaining. Get them. We're going to create a vibration damping system around the generator housing." While Rodriguez retrieved the materials, Sullivan explained his plan to Blake. "During the Gulf War, we had similar issues with auxiliary generators on the Missouri during heavy seas. We created external damping systems to reduce vibration without shutting down the generators." Blake looked skeptical. "That's not in any manual I've studied." "No," Sullivan agreed with a small smile. "Some solutions you have to invent when the situation demands it." Working together, they constructed a makeshift vibration damping system around the port generator. Using the shock absorber pads combined with reserve hydraulic fluid and flexible containment bags, they created a buffer that absorbed the most damaging vibrations while allowing the generator to continue operating. "It's not pretty," Sullivan acknowledged as they completed the improvised solution, "but it should reduce the vibration enough to prevent further deterioration." Blake studied their handiwork with newfound appreciation. "Engineering isn't always about following the blueprint, is it?" "The blueprint is just the starting point," Sullivan replied. "Real engineering happens when the blueprint meets the real world." Their solution proved effective, allowing the USS Sentinel to maintain power stability despite the worsening storm conditions. Throughout the night, they worked in shifts, constantly monitoring and adjusting systems as the ship battled its way through towering waves and howling winds. During a brief quiet moment in the early morning hours, as they shared strong coffee in the engineering office, Blake asked a question that had been forming since their first successful repair. "The modifications we've made, the improvisations, they've all worked remarkably well. Why aren't these approaches taught at the academy or included in the technical manuals?" Sullivan considered the question thoughtfully. "Some of it is institutional inertia. The Navy, like any large organization, changes slowly. But there's another factor. These techniques require judgment, experience, and intuition. They're difficult to codify into step-by-step procedures because they depend on reading the situation, sensing what the ship is telling you." "But they could be taught," Blake insisted. "Maybe not as rigid protocols, but as approaches, philosophies, ways of thinking about engineering problems." "They could," Sullivan agreed, "if someone took the time to develop a curriculum that balanced technical precision with experiential wisdom." Blake fell silent, turning this idea over in his mind as the storm continued to rage outside. By morning, the worst of the weather had passed, though the sea remained rough. Admiral Montgomery called for a status report as they approached the final day of their return journey. "We've maintained operational stability despite the storm," Blake reported. "The improvised systems have performed better than expected, though we're operating at reduced capacity." "Estimated arrival time?" Montgomery inquired. "Approximately 0800 tomorrow, Admiral, assuming current conditions." "Very good. The base commander has been briefed on our situation. Repair teams will be standing by upon our arrival." As they made their final preparations for return to Port Sullivan, found himself reflecting on the remarkable journey. What had begun as a simple consulting assignment had become something far more significant, a bridge between generations of naval engineering, between different approaches to the same fundamental challenge of keeping ships and sailors safe at sea. The following morning, as the USS Sentinel approached San Diego Naval Base, Sullivan stood on the bridge beside Admiral Montgomery, watching the shoreline grow larger on the horizon. Despite operating at reduced power, the mighty vessel navigated the harbor entrance with perfect precision, guided by the skilled hands of its crew and the innovative solutions developed over their challenging voyage. "Never thought she'd make it back with those jury-rigged systems," Montgomery commented quietly. "That was extraordinary work, Sullivan." Sullivan shook his head slightly. "It wasn't just me, Admiral. Blake and his team performed brilliantly. The young lieutenant has real potential." "He reminds me of someone I knew about 30 years ago," Montgomery replied with a knowing smile. "Young naval engineer who could feel what was wrong with a ship before the gauges showed it." Sullivan acknowledged the comparison with a nod. "Blake has more formal education than I ever did, but he's learning the things they don't teach in classrooms." As they approached the final docking maneuvers, Sullivan felt a subtle change in the ship's vibration pattern. His hand moved instinctively to the nearby railing, feeling the difference in rhythm. "Admiral," he said quietly, "we have an issue with the port maneuvering thrusters." Before Montgomery could respond, warning indicators illuminated on the bridge control panel. Blake's voice came through the takers immediately. "Bridge, this is engineering. We're showing power fluctuations in the port thruster control systems. The emergency configuration is becoming unstable under the maneuvering loads." Montgomery assessed the situation quickly. "Can you stabilize it?" "Not in time for this approach," Sullivan advised after feeling the increasing vibrations. "We need to abort and circle back." The Admiral gave the order without hesitation, trusting Sullivan's judgment. "All stop, reverse engines. We'll abort this approach and reassess." As the ship backed away from the pier, Sullivan hurried to engineering, where he found Blake and his team already working to address the problem. "The battery reserves are nearly depleted after the storm," Blake explained tersely. "The variable load demands of the thrusters are creating feedback loops in the power distribution." Sullivan assessed the situation rapidly, mentally reviewing their options. "We need to isolate the thruster control systems and provide dedicated power from whatever auxiliary batteries remain." Together, they developed a strategy to reconfigure the remaining power reserves specifically for the maneuvering thrusters. It would drain their last reserves completely, but might allow for one clean docking approach. "This is our last shot," Blake warned as they implemented the changes. "If this doesn't work, we'll be dead in the water." Sullivan nodded grimly. "Sometimes the best solutions emerge when there are no other options." The second docking attempt proceeded with tense concentration throughout the ship. In engineering, Blake called out the rapidly declining power reserves: 50%, 40%, 30%. On the bridge, Sullivan focused entirely on the ship's response to each thruster, activation feeling through the deck, how the massive vessel moved. "She's holding steady. The power flow is stable even though the reserves are draining." They approached the final positioning with battery reserves below 20%. Every adjustment had to be perfect. There wouldn't be power for corrections if they miscalculated. 15% remaining, Blake reported as the massive vessel eased sideways toward the pier. "Just a little more," Sullivan murmured, hand against the bulkhead. "She knows the way home." 5%. With remarkable precision, the USS Sentinel settled into its berth just as the last of the battery power was exhausted. The maneuvering thrusters fell silent, but they had completed their task. Deck crews immediately secured the vessel with heavy mooring lines. Admiral Montgomery's voice carried unmistakable pride as he addressed the crew. "Outstanding work by all personnel. The USS Sentinel has completed its mission and returned safely despite extraordinary challenges." Later that afternoon, as repair crews swarmed over the ship, Sullivan stood on the pier watching their activity. The massive vessel that had seemed so wounded now buzzed with the energy of restoration. Blake approached carrying a leather document case. "Mr. Sullivan, Mom," he called. "I was afraid you might have left already." Sullivan smiled slightly. "Not without saying goodbye, Lieutenant." Blake joined him, his expression animated with an enthusiasm that had been entirely absent during their first meeting. "I've been working on something I wanted to show you." He opened the document case and removed a bound report titled "The Sullivan Protocol Integrated Systems Approach to Naval Engineering." "I documented our methods, the techniques we developed during the mission," Blake explained. "I've submitted it to Naval Engineering Command as a proposed addition to standard troubleshooting procedures." Sullivan accepted the document with genuine surprise, turning it over in his weathered hands. "You named it after me." "The core principles came from your approach," Blake acknowledged. "The way you understand ships as integrated wholes rather than collections of isolated components. It's something our modern training programs have overlooked in favor of specialization." Admiral Montgomery joined them, examining the document with interest. "I've already endorsed this for implementation across the fleet, but there's something else we'd like to discuss with you, Sullivan." "The Naval Academy is establishing a new practical engineering program," Blake continued eagerly. "They need an experienced instructor who understands both the technical aspects and the intuitive elements that can't be taught from manuals alone." Sullivan understood the implication immediately. "You want me to teach, not just teach," Montgomery clarified. "Help design the curriculum. Show the next generation of naval engineers what you showed Lieutenant Blake. How to listen to a ship, not just read its gauges." The possibility had never occurred to Sullivan. At 76, he had assumed his contributions to naval engineering were behind him, limited to occasional consulting. The idea of shaping a new generation of engineers, of preserving the knowledge and intuition he'd developed over decades, was unexpectedly appealing. "I'd need to think about it," he replied cautiously. "I've never been much for classrooms." Blake smiled. "We were thinking more of a workshop approach. Hands-on training with the actual systems. Perhaps," he hesitated briefly, "we could call it the Blake Sullivan Engineering Program. A partnership combining modern technical knowledge with experiential wisdom." The suggestion touched Sullivan deeply. The proud, dismissive lieutenant from yesterday had transformed into someone who not only respected his knowledge but wanted to collaborate to preserve it for future generations. As they discussed the possibility, young Rodriguez approached in his dress uniform, accompanied by an older man who bore a striking resemblance to him. "Mr. Sullivan," Rodriguez said formally, "I'd like you to meet my grandfather." The elder Rodriguez stepped forward, extending his hand. "Miguel Rodriguez, Chief Petty Officer, retired. USS Enterprise, 1975. You saved our engine room during that North Atlantic storm." "Never forgot it." Sullivan's face lit with recognition as he shook the man's hand warmly. "Miguel, the steadiest hands in the division. Never thought I'd see the Navy finally recognize what you've been trying to tell them for decades," the elder Rodriguez said. "Ships aren't just machines. They have souls." This reunion, perhaps more than the formal proposal, convinced Sullivan of the value in sharing his knowledge more systematically. The continuity of wisdom across generations, from Sullivan to Blake, from the elder Rodriguez to his grandson, represented something precious that shouldn't be lost. 3 months later, the first class of the Blake Sullivan Engineering Program gathered at the Naval Academy's practical training facility. 25 engineering officers stood attentively as Sullivan and Blake prepared to begin the inaugural session. Sullivan surveyed the faces before him, young men and women representing the future of naval engineering. Among them was Ensign Thomas Rodriguez, who had completed officer training and requested assignment to the program. "Engineering is both science and art." Sullivan began, his voice carrying the authority of decades of experience. "The science can be learned from books and lectures. The art must be acquired through practice and observation." Blake stepped forward. "Together, we're going to teach you how to understand ships as integrated wholes, how to listen to what they're telling you, how to combine technical precision with experiential wisdom." Sullivan nodded in agreement. "And we're going to start by listening to the USS Sentinel. The ship has stories to tell if you know how to hear them." As he led the class toward the training vessel, Sullivan felt a profound satisfaction. His life's work, his understanding of ships and systems, wouldn't end with him. Through Blake, through Rodriguez, through all these eager young officers, his knowledge would continue evolving and growing as it passed from generation to generation. That evening, Sullivan returned to his small home, weary but content. On his desk sat a framed photograph of the USS Sentinel alongside a new plaque bearing the insignia of the Blake Sullivan Engineering Program, a modern digital gauge overlaid on an old-fashioned analog dial, symbolizing the union of traditional wisdom and contemporary technology. He picked up the worn photograph of his late wife, Margaret, that had kept him company through lonely years. "You'd like this, Maggie," he said softly. "They're actually listening now." The true legacy of a master isn't measured in accolades or recognition, Sullivan reflected, but in the wisdom passed on in lives saved by lessons learned, in traditions preserved and enhanced by each new generation. As he sat in his quiet home with memories of ships and sea surrounding him, James Sullivan knew he had found something more valuable than any technical problem solved or engineering challenge overcome. He had found continuity, the assurance that what he knew, what he had learned through decades of listening to ships, would not be lost, but would instead grow and evolve in the capable hands of Blake Rodriguez and all who would follow. It was, he thought, as he gazed at Margaret's smiling face, precisely what she would have called a life well lived.